This is Physical Science, AMI Day 28. This is the way this item appears in the packet. A wave is a disturbance that transfers energy from one place to another. Most kinds of waves need something to travel through. The material through which a wave travels is called a medium. Waves that must have a medium to travel are called mechanical waves. There are other waves that do not have a medium to travel. Sunlight, X-rays, etc. They're called electromagnetic waves. There are two types of mechanical waves, transverse and longitudinal. The diagram shows a transverse wave. The basic properties of waves are amplitude, wavelength, frequency, and speed. Amplitude is the maximum distance the medium moves up or down from its rest position. The greater the energy, the higher the amplitude. Wavelength is the distance between two matching parts of a wave, crest to repeating crest. Wave frequency is the number of complete waves that pass a given point in a certain amount of time. Speed of a wave is dependent on wavelength and frequency of the wave. Here's our diagram here showing a transverse wave. We have the crest, the amplitude, the wavelength, and the trough. For our questions here we have with this problem, we need to focus here on the wavelength. So, in answering these questions, we really need to take a look here at the wave speed formula that we're given. So this relationship is that speed, which is measured in meters per second, is equal to the wavelength, measured in meters, multiplied by the frequency, which is measured in hertz. So let's read. A wave's frequency is 2 hertz, and its wavelength is 4 meters. What is the wave speed? So we're going to have to do some multiplication here in our formula. We need to focus on these two values here and go ahead and calculate and report that speed. Let's look at number 2. Two waves have the same speed. Wave 1 has a wavelength twice the length of wave 2. How do the frequencies compare? It has a sentence frame that we can choose to use. Okay, so I've highlighted the different parts of the formula that we need to use. What I've done here is I've made sense of the language in the question, and I've plugged in numerical values to match what the statement says. So as I read, follow along and look at wave 1 and 2 with numbers plugged in. So two waves have the same speed. That's 20 meters per second in our example. Wave 1 has a wavelength twice the length of wave 2. So if we look at wave 1, its wavelength is 10 meters. 10 meters is twice that of wave 2, which is 5 meters. So the question now asks you, how do the frequencies compare? So that's asking about the hertz. I hope this video helps you successfully answer these questions. Be sure to email your teachers if you have any questions.